Hi everyone, my name is Mahendra. Welcome to my channel. Today I would like to explain on motion and types of motion. Here you can see there is a boy and the boy is standing beside the road and here is a car. If we observe the position of the car with respect to the boy, the car is not changing its place. It is fixed at one point. So we can say that the car is at rest with respect to the boy. So what is the rest definition? An object is said to be rest if there is no change in its position with respect to the surroundings in the given time. So the car is at rest. Let us see the next case. Now the car is moving. It means the car is changing its position with respect to the houses and the boy. Then we can say that the car is in motion. An object is said to be in motion if it changes its position with respect to its surroundings in given time. Here is a forest. You can see some animals are there in the forest. Oh, it's a dinosaur. It is in motion. It is changing its position with respect to the trees. There is a drone in the sky and the drone is changing its position with respect to the clouds. So the drone is in motion. Let us see this example. The car is traveling on the road. The initial time the car did not travel any distance 0 meters only. After 10 seconds the car traveled 150 meters. After 20 seconds it traveled 300 meters. After 30 seconds it traveled 450 meters. Next 40 seconds after it traveled 600 meters. If we observe the time, first 10 seconds the car has traveled 150 meters and next 10 seconds also it has traveled again 150 meters only. For every 10 seconds the car is traveling 150 meters distance. So we can say that when an object covers equal distances in equal interval of time, it is said to be uniform motion. So the car is now traveling in uniform motion. Let us see the another situation. Observe the speed of the car and next you see in this case now the speed has increased and afterwards speed decreased and next speed of the car again increased. It is going very fastly. So if we observe the time and distance, so starting time the car is at 0 meters and after 10 seconds the car has traveled 50 meters. Next after 10 seconds also it traveled 90 meters. Next 10 seconds it traveled 180 meters. Next 10 seconds after it has traveled 230 meters. It means if you observe here the equal distance are not covered by the car. First 10 seconds it has traveled 50 meters. Next 10 seconds time it has traveled only 40 meters. And next 10 seconds after it has traveled 90 meters. So the object is covering unequal distances in equal interval of time. It is said to be non-uniform motion. So if a body covers unequal distances in equal interval of time, it is said to be non-uniform motion. Identifying uniform and non-uniform motion. When it is a uniform motion, we represent with U, and it is a non-uniform motion, we represent with NU. First one, movement of hands of clock. If you observe the movements of hands of the clock, they all go at a particular time. So seconds hands takes only 60 seconds for 1 minute. So every time it takes same time. So it is a uniform motion. Movements of hands of a clock is a uniform motion. You will write. A boy cycling in the crowded place. So he has to change his speed. So it is a non-uniform motion. And next, movement of housefly or any insect, it goes non-uniform motion. The fan in air cooler or blades of the ceiling fan at a fixed point. So the blades moves in uniform motion. A train entering into the railway station. So when station approaches, the train decreases its speed. It means it is a non-uniform motion. Kite in the air. So it also example of non-uniform motion. Rotation of earth. Earth takes 24 hours to rotate itself. So it is a uniform motion. So these are the examples of uniform motion and non-uniform motion. Types of motion. Observe the following table and state paths of motion each case by ticking right mark in relevant column. Soldiers marching in a parade. So it is a straight line. Car taking turn on the road. It is a curved line. Stone dropped from height. Straight line. Running race along the road. It is also straight line. Running race along a track on the road. Curved line. Movement of bicycle on the road. Straight line. So this is the path of the objects. In the above all cases, all the points of moving object in the same direction of the motion. So all the body parts of the moving object will go in the direction of motion. Such type of motion is known as a translatory motion. If all parts of moving body move in the direction of motion, then the motion is said to be translatory motion. So in the above all examples are translatory motion only, all the objects. See this, the car is moving towards right, so it is in translatory motion, as well as the car is moving in a straight line. So object is in translatory as well as it is going in a straight line. Such type of motion is known as rectilinear motion. If a body in translatory motion moves along a straight line, the motion is called rectilinear motion. Now see this van, and it is moving right and turning and going in another direction. So the path of the van is in a curved path. So curvilinear motion. What is curvilinear motion? If a body in translatory motion moves along a curved path, then the motion is called curvilinear motion. So in translatory there are two types. One is rectilinear motion, another one is curvilinear motion. We have to identify types of motion, whether it is a rectilinear, indicate with R, curvilinear indicate with C, and if both rectilinear and curvilinear means we have to indicate with RC. Seconds, hand of a watch. It is a curvilinear motion. Movement of train on the tracks. It is rectilinear and curvilinear RC. Movement of a tape in tape recorder. It is a curvilinear motion. Movement of needle in speedometer. It shows 20 km per hour, 40 like that. It is also curvilinear motion. Movement of a bus on hill station road. It goes in curved path, curvilinear motion. Motion of coins on a carom board. It is a rectilinear motion. It goes straight only. Motion of ball in pinboard. It is also rectilinear motion. Motion of a mango falling from tree. Rectilinear motion. So these are the examples for rectilinear, curvilinear and rectilinear and curvilinear. If you observe here, Earth rotates itself and it takes 24 hours and it rotates along an imaginary axis. So such type of motion is known as rotatory motion. And the wheels of the car. These are also examples of rotatory motion. Hands of a wall clock also are in the rotatory motion. Blades of a ceiling fan. These are also in rotatory motion. Rotatory motion means the motion of all particles of moving body follow a circular path with respect to a fixed center or axis of rotation. Here is a football on the ground. If it moves forward, what type of motion is this? Here two motions are there. One is rectilinear and rotatory and translatory motion. So it is a rotatory motion and translatory motion. Observe the following motions and we have to identify which is rotatory, translatory and translatory and rotatory. Motion of blades of a ceiling fan. Rotatory motion. Motion of an arrow from a bow. It is translatory motion T. Motion of earth around the sun. Translatory and rotatory TR. Motion of a drill bit. TR. Translatory, rotatory, both. Motion of wheels of an object. Translatory and rotatory. Next one is oscillatory motion. So when an object moves forward and backward, or we can say to and fro motion of the object, such type of motion is known as oscillatory motion. So example is simple pendulum. It is in the oscillatory motion. Next is swing. When it is moving also it goes forward and backward or to or fro motion. It is also in oscillatory motion. A needle in the sewing machine. It is also moves up and down to a fixed point. So it is also in oscillatory motion. What is oscillatory motion? The to and fro motion of an object about a fixed point always following the same path is called oscillatory motion. Here we have to identify oscillatory motions. A spinning top. No, it is not an oscillatory motion. Bullet fired from the gun. It is also not oscillatory motion. Typewriter key. Yes, it is a oscillatory motion. Motion of potter's wheel. No, it is not a oscillatory motion. Motion of vibrating sitar string. Yes, it is a oscillatory motion. Motion of car taking a turn while moving. No. Ringing bell. Yes, it is oscillatory. Bouncing ball. It is also oscillatory. So these are the examples which are in the oscillatory motion. Thanks for watching this video.